Hello guys, welcome back to Chemistry Study Group. In this video, we'll learn how to draw line structure and to name them using the IUPAC standard. Alright, so we'll take the first one. Here we have 4 carbon chain, 1, 2, 3, 4. So 4 carbon chain that are all single bonded is butane. So we have butane here. This is butane, right? Okay, this is butane. Alright, now if you look at this, every end of the line without an attachment is a carbon. Take note, every end of the line without an attachment is a carbon. So this is an end of the line. There is no attachment, there is no substituent here. So this is a carbon. One, this is another carbon. This is another carbon. This is another carbon. So number one, I said every end of the line without an attachment is a carbon. And where two carbon or two lines meet, a point where two lines meet is also a carbon, just like this point now. Okay, this line and this line meet at this point, so this must be a carbon. All right, so this line and this line meet, this must be a carbon again. Then every end of the line without an attachment is a carbon. Please take note of this because we are going to be doing some other examples later that will seem to be confusing, but understanding this will help you greatly. All right, so this is also butane. So if you count it now, 1, 2, 3, 4 is also butane. So we seem not to be showing the number of hydrogen. So if this is a carbon, definitely you know that carbon should be completed tetravalency, right? So that we can have one hydrogen here, one hydrogen here, one hydrogen here. This is a carbon that has 4 bonds, 1, 2, 3, 4. But we will not show the bonds. All right, we will not show the hydrogen because this is line structure. Okay, so this is another carbon now. Since it have 1 bond, 2 bonds, so it needs to be 3 bonds and 4 bonds. So this CH3, this is the CH3. This CH2, this is the CH2, right? Then they will have another H2 again. So if this is a carbon, this is another bond here again. All right, so this is carbon surrounded by 4 bonds. Then this is CH3. Then this is a carbon with what? 3 hydrogen to complete the tetravalency of carbon. So this is it. You need not to write all this, right? So we'll just go ahead and do something like this. Okay, this is enough. 1, 2, 3, 4, and it is called butane. Now look at this. Look at this. We have 2-methyl butane. This is position 1. This is position 2, this is position 3, and this is position 4, right? At position 2, we have methyl, right? So we call it 2-methyl butane. So this is 2-methyl butane, right? Now let's draw the line structure of 2-methyl butane. The first thing to do is to draw the longest carbon chain. The longest carbon chain is 4. 1, 2, 3, 4. So we draw 4 carbon chain. So the end of the line, okay, no attachment. This is 1 carbon, this another carbon, this another carbon. That is making 3 here, right? Then 4, this another carbon. So 1 carbon, 2 carbon, 3 carbon, 4 carbon. This is the butane. Then at position 1, position 2, position 3, and position 4. At position 2 here, we have what? Methyl. So you add a stripe. Don't forget, every end of the line is a carbon. So adding a stripe like this represents what? CH3. Why do I say so? Remember, if the end of the line is a carbon, it must have what? 3 hydrogen. CH3. Okay, so that will have what? CH3. So this is it. This is the same thing as saying 2-methyl butane. Same thing as this. Are we together now? Now look at this one now. Determine the longest carbon chain still. 1, 2, 3, 4. 4 carbon chain. At position 2 we have bromine. So we have 2-bromo butane. So 2-bromo butane. Now let's draw the line structure. Beginning of the line is a carbon. 1, 2, 3, 4, right? 1, 2, 3, 4. So this is it. At position 2 we have bromine. Here we'll draw the stripe, then add our bromine. Okay, if you didn't add this bromine now, it makes this end of the line a carbon. But because there is an attachment, this is no more a carbon but a mere bond from this carbon to bromine. Are we together now? So since there is no since there is an attachment which is a substituent, this end of the line is no more a carbon but a bond from this carbon to bromine. So this is it. Are we together now? So for the last one now, we have 4 carbon chain. 1, 2, 3, 4, right? So we have 1, 2, 3, 4. Now this is where many scientists get confused. Now, at position 1, we have bromine. Remember, this is our 4 carbon chain, right? This is position 1, position 2, position 3, position 4. Because this is 1, we must give substituent lowest possible number, right? 1, 2, 3, 4. So we say 1, 3 dibromo, 1, 3 dibromo, then butane, right? 1, 3 dibromobutane. Now look at it. If we want to give this bromine substituent here now, we will not write the bromine substituent here. We will not say it like this. No. If we do it like this, we have cancelled this carbon that is at this end of the line. We have cancelled it. So we will not write the bromine here. Instead, we'll do something like this. Okay? Instead, we'll do something like this. Right? This is 4 carbon chain. 1, 2, 3, and 4. So instead of writing the bromine here, we'll take another line, a bond, and then put our attachment, so that this will not be a carbon but just a bond to this carbon, so that our carbon 1 will still exist. But if we do it like this, our carbon 1 is no more there. So we have reduced this chain to be what? 1, 2, 3 carbon chain instead of 4. So this is how we'll do it, right? So from here now, we'll take a bond, we'll take a new bond to attach our substituent, and at position 3 we have another bromine. Then you can just put your bromine here, and then we have 1, 3 dibromobutane as this. Okay, so this is the simplest way to draw line structure. If you have any question, you need clarification, yeah, just go ahead and drop it in the comment section. I'll be there waiting for you to reply all your questions to clarify every misconception concerning line structures and IUPAC nomenclature. So if this video made sense to you, don't forget to like, share, and follow us for more. God bless you.